Hi everyone, this is the third video in our projectile motion sequence. So this is the scenario where they start and land at different heights. So again, we'll just write down what information we have. We start at a height of 4 meters, and this time we end at a height of 6 meters. Our initial velocity, 30 meters per second at 23. So it's the same scenario from the last question. I've changed it to a bike and you're jumping on a building. The same thing, we want to know the time of the year, so we use the same formula again. V(y)0 times the time plus 1/2 at squared. By now you should be knowing where these numbers come from. So this is 6, this is 4, this is going to be 30 times the sine of 20 degrees times t plus 1/2 9.8 t squared. And so when I have this, I can't move terms around and cancel things out. I've got all the terms, so I'm going to have to make it into a general form. So I'm going to make this side equal 0. I'm going to move the 6 over and I get negative 2 plus, this is 10.26 t minus 4.9 t squared. So I'm at this point. This is my C term, this is my B, and this is my, move my video here, my A term. So now I need a quadratic solver, so I'm going to state use quad solver. You have to add that in so that whoever's looking at this knows how you got from here to the answer. So the answer for this, give me a second to put it in my solver. So I put these numbers in my solver and I get 0.22 and 1.88 seconds. So both these answers tell you something. Since the trajectory of this is, the ramp is here and the building is higher, as they jump over it onto the top like this, and that's not a perfect parabola, it means that you're at the height of the building at the beginning at 0.22 seconds and then again at 1.88. So this is the important number. So the time of the year is that. We want to find the range. So part B is how far away does it have to be. X equals x0 plus vxt. So x equals v0 cos theta. So that would be 30 cos of 20. Times the 1.88, and that should give me an answer of, that gives me a number of 53.00 when I round it off, 52.9986 or something like that. So 53 meters away would be where the very farthest away you want the building in order to land on the top of it. So hope that makes sense. Now we talked, so we gone through these now, 3 examples. They all use the same formula. Your difference is what goes in for y, y0, and your vy0, and how they affect your question. You can use the quadratic solver for all of these. So I'm just going to take a second and go to the solver that I made the other day. And in my solver, I put the 30, the 20 degrees, and a starting height of -2, and it gives me my numbers. So it gives me my y0, vy0, and vx0, the time of the year 1.88, which is rounded, and the range is 52.9, which is slightly less, but that's because this number is rounded up. So went a little further, the longer you're in the air, the more difference it makes. The other question had an initial height difference of 0. So I've done the thinking in this. And the other question we don't have to do the thinking. So if I put a 0 in there, you'll notice we got the 2.09, which was the same answer we had in the second video, in 59.03 meters. And then in the first question, we had initial velocity of 100, the angle was 0, and the initial height was 3,000 meters. And that gives me a time of 24.74 and a range of 2,474, which were the numbers that we had in the first question. So if you have a solver like this, it does all the work for you. You had to work it out, but I can go through all my questions. I can check all my answers quickly and solve them without having to use my calculator now that I've created my formula. And that formula is the quadratic formula just rearranged. I only need one version because I only need the version that's going to give me the bigger answer. I don't need the version that'll give you the smaller answer. So time in the air, if I were going to say, well, then what happens if I go at a height of 2,000 meters, changes my numbers for me automatically. So it's a great little tool. Those of you taking physics next year, I strongly suggest that you try to make one of these, and maybe I'll throw a video together early next week, so just give you an idea how to do it. All right, I hope that helps. Thank you very much. Talk to you later.